have been seeing that quite a lot of things happening in this area, and especially after COVID-19. So a lot of research papers are being published on this. We have been how the relationship between various or maybe among various supply chains, certain things like the related data. Because as such finance, you get a lot of secondary data. Because what is that is really very very difficult, because we basically depend not on the scale. Cross sectional data in this area is resilient, right? So we never knew that there will be COVID-19, and that will be creating the problem for about 2 years across the globe, right? So now we are trying to come back to the normal position where everything will be normal. So in case there is any unfortunate event happens in the future, how quickly people can come back to their normal position. So there is a lot of work going in terms of the resilience. So now I'll not be really getting into too much details of the supply chains and the type of supply chains, and there is a trade-off fitting into the responsive supply chain. There may be a trade-off, we can say, right? So it can be coming under the efficient supply chain, because we basically talk about the cost. Similarly, if we talk about let's say the basically say in the in the supply chain literature, we basically talk about the efficiency in terms of the cost. Looking for the minimizing the cost is not a good idea. So if the uncertainty is very low, then looking for the response those on real-time basis, and so in that way the multi-inventory can basically cost. For instance, if I say right. So descriptive analytics, and the second thing is that the prediction. Here, between descriptive and the prediction, people are also talking about some prediction, basically the data. So what kind of data is available? So whether the data is cross-sectional, that means the data have been collected in a single period of time. Then, so we can use the time series and the forecasting methods. We can also then we have the prescriptive analytics. It is actually optimizing technique, right? It's nothing great we are talking here, but only the nomenclature have changed to the prescriptive analytics. What is the prescription? This will be basically talking that what we should do, right? Here what is happening and where what is going to happen. So it's like we have to forecast, and here what action we should take, right? Like how I have said previously, that if you are operating in a chain, right? So how, let's say this is a focal form, let's say this is a focal form 2, and how this focal form 1 can collaborate with. So that way we have quite a lot of techniques available. Let's say linear programming, then MILP, mixed integer linear programming, and so on. Then simulation. So simulation is another classic technique. There actually, so you can probably use R and Python. You can also use some subscription based software. So you can probably try with the greenfield analysis, or you can say delivery of the material. So you can before it. Then the filling rate. This is one high-level metric. Those who are teaching, supply chain may be knowing there's something called expected shortage, right? So expected shortage per cycle. Okay, so this is a very high-level metric. So though it is looking like filling rate is, I ask for 100, you give me 90. So you cannot say that 90% is the filling rate, right? So because it is basically stochastic, the behavior is basically stochastic. It is not really the deterministic, right? So you have to use expected shortage, and 1 minus expected shortage, you can say is the filling rate, right? Is the filling rate. So for finding the expected shortage, you have to see the cycle service level, how often the cycle is, the demand is fulfilled in a cycle without any shortage. So that is a very, very classic problem. And if it is a multi-level supply chain, then that will be much more challenging, because as I said, if there are two stages in the supply chain, one is operating at the rate of 90% and performance, right? And if you see the superior performance, I've removed, there is one, you can say the best performers, okay, that is much more higher. So the 5 days, there should be 500 kilometers, okay, or maybe around so 2005. Like India, we have seen that a truck basically covers about 300-400 kilometers, not more than that, or maybe at the best 500 kilometers. So then it is a challenging situation. So we'll be performing probably here. Then the second one is the internal assessment. So the production flexibility. So if there is a change in the market and you would like to tap the extra demand, then how many days somebody takes to cope up with the challenge? So it takes, for average performance, it takes 25 days. So people, are not from the supply chain background, may be thinking that 25 days is a very big time, so people can really cope up with that. Please do not be under that impression, because the aggregate plan and the infrastructural issues may not really support for the production flexibility, right? If the capacity chunk is not available, so extra capacity is not available, then you will be basically looking for the outsourcing. And when we go for the outsourcing, then a lot of issues with respect to the coordination, quality problems, standardization will be coming into picture. It may not be that easy to talk about it. And again, for the supplier, you can superior performer, so is experimenting with respect to 20 days. That is again very, very interesting thing, or maybe very, very challenging thing. So 25 days is quite less time, so you can think of 20 days, right? So then again, the few things with respect to the score analytics, you have total cost of logistics. Logistics is again people, those who are not familiar, orientation for research, and someone interested can probably take it further, and any further issues and needs discussion or something, maybe over a period of time, we can be in touch, and we can probably help each other to see how the data can be collected, and how well we can probably add value to this particular research. So the value addition for employee is you can see this is 306,000 US dollars, and the superior performance is 460,000 US dollars. So you can compare the organization wherever you are working. You can take the total productivity, maybe you can say total sales, right? The classic example, I have not shown the sub metric, so you can probably say this is sales. You can take the sales by number of employees working in the organization. You can see that is the value addition per employee. So that is very, very interesting for this score metric. Then finally, the asset we are talking about the inventory days of supply. People from finance may be knowing that inventory turnover ratio. Then we talk about the cash to cash cycle time. This is again a very high level metric. This is a very high level metric. Here we basically talk about inventory days of supply, then days of supply outstanding, right? Minus, you can say the inventory turnover that is available, or you can say the please don't take it as a kind of a rule of thumb, or something which should happen in every supply chain. So, the inventory is found, to cause roughly 0.22, percent increase in the sales. That means what is happening here is 1% increase in inventory, right? So 1% increase in the inventory is likely to have the chance that 22% will be sold. So this is just to say that, what happens with respect to the holding stock, right? So it may not be true for all the cases, but, that way, so holding cost may be very, very high, right? So then with respect to a little bit of prediction, so these are the few methods maybe knowing that, there are some classic cases with respect to moving average, right? Then we have the exponential smoothing that we use. Then another method is Holt Winters method. Here we can address the trend as well as the seasonality problems. Then the classic regression based model with respect to time series data, time series cross sectional, that becomes the panel data. So that you can see with respect to the fixed, the few other methods are, Box Jenkins methodology. Some of you may be knowing, that is the pioneer of the ARIMA model, auto-regressive integrated moving average method. So this is a kind of a multiple, you can say the combination. You can say there is a seasonality, then there is auto-regression, there is integration, there is moving average, right? Then here, the same thing we are talking here, but this is with respect to exogenous variable. And if the exogenous variable also depend on, you can say that is yt minus 1, okay, let's say a1 yt minus 1. This is like a simple, AR model. So if you want to take the, past values of the independent variable, right, that becomes a kind of a auto-regressive distributed lag model. So there, if you do not want this time lag, that simply becomes this Aremax model. So maybe down the line, you can probably explore, and few methods I'll just show you quickly, because in 1.5 hours, I cannot really, do justice to all these things that I'm demonstrating, but you can slowly explore. If you have any further queries or concern, maybe we can see at a later stage. You can exchange mail, or you can call us. We'll see how best we can help each other. Then the other predictive models is a multivariate regression model. I think some of the sessions have been scheduled for multiple regression. There you can see. Then some models with respect to the hierarchical. Here the theory you need to take into consideration, and accordingly you can increase the variable in the multivariate regression depending on the theoretical evidence. Then this is another interesting model you might have heard of regression. There is stepwise regression. So stepwise regression, you see that the best features basically taken into consideration to give you the the model, and multiple models you'll be getting. If y is equal to a plus bx, then you'll be getting y is equal to a plus b1 x1 plus b2 x2 and so on. Then x2 may be a function of x1. So that way you can remove probably x2, because x1 is broadly controlling the regression. So that way these are the extra features available. I basically do it in Python. So maybe you can experiment with the R also. The logistic regression, this is actually the stochastic behavior that happens with respect to, the dependent variable will have multiple categories, yes, no type of category, or it may be more than 2 categories, right? For instance, if I say that someone is smoking, and what is the possibility that he or she will be getting some problems, right, with respect to the respiration. So we can say it may be yes, it may be no, then we'll be using this kind of regression. Then there is another interesting, the hyperplane. So that is the support vector regression thing, and most of the times you have seen that it also gives a good result. Then the tree-based model, I'm getting some noise, please mute yourself. Then the tree-based model, so this is can you please mute ma'am? Tree-based model, that also is possible. Then the neural network-based model, basically we use in the prediction, supply chain prediction, we use a recurrent neural network. Then for the prescriptive model, we, as I said earlier, we can use linear programming, we can use MILP, then some queuing theories basically used in the services. Then with respect to the system dynamics, there's a kind of a simulation model. Then game theory, I have already told you about that. Then with respect to the time, we can probably see the dynamic programming. Here actually one thing we also see, there is something, there is a method called, you can say with respect to the time that we see how things basically vary, and we with the past events, how they can control maybe kind of a variable that you have taken, the lag, how the past behavior is controlling the future. Then the multi-criteria decision making, here we have certain methods available. You can say ASP, that is analytic hierarchy process, or you can say simple models like weighted average method also can be taken as a multi-criteria decision making problem. We have DMATL, we have TOPSIS. There are certain methods available in this multi-criteria decision making. Now I'll just take you through 15-20 minutes through my, it will be the thing. So please have a look at it. I'm not going to do it here because that takes actually more than one class. So I'll just show you, and what you can do is you're presenting here. What you can do is you can probably move the cursor, right? Because if I do it here, it will take another 1.5 hours at least. So I don't want to take any further time because the time allotted is up to 8. So please see, this is one interesting thing. I'll be sharing the Excel sheet. You can just move the cursor to see how these values have been calculated. Let's have a look at it. This is the data that I have taken from Kaggle, and here you are going to predict. Let's say this is January 2007. Certain, to some extent it has been customized. So then this is March, because why you will not be accurate, because there is a lot of seasonal fluctuations. So the best method for this could be the Holt-Winters method. Anyway, Holt-Winters method is takes at least 1.5 hours to explain. So I'll just show you through few methods, right? That is, let's say, weighted moving average. So what is that I'm going to do here is I have taken for 3 different periods, W1, W2, and W3. So that means what I am trying to say is, let's say I'm keeping the cursor here. Okay, you can see the cursor. I have to increase a little bit of size so you can watch it. So you can see these are the different weightages I've given, right? That means I'm giving, this seems to be, already, you can say, let me just change it to some extent. You will be able to see, let's say 0.25, right? Then I'll be giving 0.25, okay, 0.5, right? So then you can do one thing here, that is equal to sum of these 3, right? So the weightages I'm giving for every single value. So 100 is 100%. So that means if you see that this into 0.25, this into 0.25, then 185, that is this into 0.5. So that means I'm giving 25% weightage to this, then 25% weightage to this, and 50% weightage to this, right? And total is 100%. So now I'm able to calculate all these values, and as you see that this is the value that I've calculated. So you can simply drag. I'm getting some noise, please mute yourself. So you can do that. So you're getting the values with respect to so this is what is the value. Then you will be getting 06. This has to be fixed, 06. Then you can see that what will be varying is, these are the part what will be varying. So what will be the constant? What will be the constant? I'm just going back because it takes time to do it now. So you can simply keep the cursor. So what this is coming up with the 25% weightage, or now with this, what is happening is 0% weightage given to this one, 0% weightage given to this one, 99% weightage is given to this one. So what is that I have done is, you may ask that question. I have gone through the error, and the error has been minimized. Okay, so like you can see that this is what is the calculation. So if I show you quickly one thing, that is this into I said this one, okay, plus this into this one, then plus this, or you can say that is C2, C3, C4 into this one, right? So likewise, if you extend, you'll be getting all these values. Okay, then after you get these values, what is that you are going to do is, you have to just take one step ahead. Whatever you calculate, let's say in the month of March, is going to be the forecast for the month of April. So one step ahead you can do. That means the last period what you have here is 599.92. That way will be your forecast for the 3 different periods. Now you may ask, what is why these 3 periods are not changing? They're same. I'll say that this is a method that we are using here is basically a method that does not address any seasonality or any trend. That is why whatever we calculate here, we are keeping here. Now you may say in the supply chain, this may not be true. I say it may be true in some cases. Let's say grocery supply chain. So for the grocery supply chain, we don't have much seasonality, right? So that means you can say rice or wheat flour or maybe something edible oil. So you can simply predict with this method. So don't be under impression that this is a simple method. So it's a useless method. That is not correct. So then you calculate the error. So as you see from here to here, we do not have the data available, right? Due to the paucity of the time, I'm not going to discuss the details of it, but you can keep the cursor. If you have any queries or concern, you can probably get back. So this one is coming here, this one is coming here, and so on. Then you are calculating the error. What is the error? Error is nothing but demand minus forecast, or maybe forecast minus demand. Anything is fine. So that way you'll be getting the error. So likewise, you just drag it, right? You can drag it, then you take the absolute value, then you square it, and you take a cumulative value. Square of this is this, square of this plus square of this is equal to this, square of this, square of this, square of this, square of this divided by 3 is equal to this. Likewise, you can calculate. Similarly, you can calculate the mean absolute deviation. This is called as mean squared error. That is the square of this value, right? Then you take square error square, then you take mean, right? Mean means the average you have to take all the times. So here you have to take the deviation, that is absolute mean absolute deviation. You can see the formula mean absolute deviation. So then you take this one is equal to this one. So second one will be this one plus this one divided by 2. All the formulas have been given, here in the you can say the calculation bar. You can see how it is calculated. You can keep the cursor and see. So that way we have calculated the MAT. Then last one is error percentage. Error percentage is nothing but the absolute error percentage. This is the error divided by the total. This one divided by this one divided by the into 100. So you'll be getting this value. Similarly, you just drag it. You do not have to calculate everything. You can simply drag and drop. Then you calculate absolute percentage error. This one is equal to this one. Second one will be this one plus this one. You have to take cumulatively, right? Then finally, you will be getting something called tracking signal. Tracking signal is something, with respect to, you can say the error that you will be adding. This one divided by MAT. This one divided by MAT. That is error, summation of all the errors cumulatively divided by MAT. So this one plus this one divided by this one. You'll be getting this one. Likewise, you can do that. So finally, you got the at the end of the year or at the end of the planning horizon, you are going to get the MAPE, MAPE of that is the K column. You can see the K column we're getting 10.8%. So even though we had a lot of fluctuations in the data, still we are able to get 10.8% error. That means you can see it's a very highly accurate forecast. 10.8% error. That means 11% error, 89% accuracy in the supply chain is not a very bad figure, right? So, but you can still control it, right? Now, what you can do is, if you want to still control this, what you can do is you can go for a little bit of linear programming. So you can go to your Excel solver, right? So you can go to Excel solver. Then in the Excel solver, what you can do is you can keep this value, and you have to minimize that value by changing the cells, right? By changing the cells, that is, you can see what are the cells we are going to we can change. The weightages we can change, right? The weightages we can change. Just you drag it there. Then as you know that weightages cannot be negative, right? So they have to be either positive or 0, and sum of all the weightages should be less than or equal to 1. That way, if you go for the solver and solve it, let me show you, solve it. So you'll be getting, solver has found a solution. So you'll be getting this value. That means the weightage of 1 is 0, weightage of second one is 0, then what is of 3 is 99%, it is 99%. So ideally it should be 100%, but due to some error it is showing 99%. So that way you are seeing that there is an error percentage of 10.8%, which is a very good figure in terms of the analysis. Similarly, the same thing have been performed in this case, and that is basically the exponential smoothing problem, right? In the exponential smoothing problem, you may be knowing there are two issues. One is the demand and one is the forecast, right? The demand is to some extent responsible for the forecast, and forecast is also responsible for the forecast, right? So that way you have to find the average of all the demands given, and you take this as, you know, there are certain things what you calculate here, what you forecast here, then the error, then the absolute error, like the previous case. Then it is like, you know, you might have you might be knowing in case of an exponential smoothing problem, that is what we basically do is we basically take with respect to you can say that alpha, right, dt plus 1 minus alpha, I'm just putting this way, 1 minus alpha into ft, right? So this is what is your forecast for the period t plus 1, right? So this is what you can see, 50%. If you say alpha is equal to 50%, so that means alpha is equal to 50%. If you say 50%, if you say alpha is equal to 50%, right? So that means alpha is equal to 50%, that means 0.5. So that means you are giving 50% weightage to the actual demand and another 50% weightage you are giving to the forecast. So that way you have to calculate using this formula that have been calculated, and you will be coming able to solve that thing. So finally, if you want to use solver, you can also use the solver. Everything is fixed. You just have to use solver, or maybe you have to install through add-on in your Excel sheet to get this value. So I have solved it. So I'm getting 12% error, right? I'm getting 12% error, that is MAP. So that means I can see that moving average was slightly better. Weighted moving average was slightly better than the exponential smoothing. Similarly, regression. You are familiar with the regression. Everybody knows about the regression. Y is equal to A plus BX. Here it is demand is equal to A plus coefficient times T. So that way you can calculate, there are two arrays. This is one array, this is one array, and you find the intercept and you find the slope, right? That way you again repeat the procedure. Then you are getting something called let's say, what is that you are getting? 15.91 is there, right? Here you cannot really optimize because it is already found, right? You cannot coefficient or maybe intercept, you cannot optimize. It is already optimized because we basically use in the regression ordinary least square, right? So it is already optimized because we take the error to try to minimize the error, and already it is optimized. So 15.91. So you may be wondering, why is this error higher? Okay, as I said, we have run the algorithm for 3 different procedure or 3 different same data we have run through the 3 different algorithms, but we are unfortunately getting little higher even though it is addressing the trend, right? So we cannot really say that a method which is simpler is not very useful, right? So it is already optimized. So 15.91, that way your forecast values are also changing. So higher forecast values may be giving you higher holding cost, which may not be good for the supply chain. The another thing is that another method where regression is the initial requirement, right? So we got you can see 122.68, 3.68. These are the 2 values that we got, and we kept it here in terms of level and the trend. Then we are using, actually this method is called a double exponential smoothing method. That means we need 2 different smoothing constant. One is alpha, another one is beta. So that means we have to give some weightage to to this value. That means initially we have this value, that is the intercept. This is nothing but your trend. So now this one plus this one is equal to this one. We have calculated. Now when you go for the second calculation, you have to take alpha times of the level plus beta times of the trend, or you can say alpha times of this value, that is C3, this value, plus beta times, you can see the beta times, or you can say 1 minus, this is for LT or the level that we are taking alpha here, and the trend we are taking basically for the beta. So this is, you can say, alpha of this one plus 1 minus alpha of, that is P4, 1 minus alpha of the trend, level plus trend, right? This will be giving you the value. This is the algorithm, the requirement. So you can keep the cursor and see. Then if you want to find this is the initial trend available, then you have to find the second trend. So second trend will be the trend that is already available. That is, you can see that is the trend that is available is 3.62. So that means you have to see the change in the trend. What is that? Is the change in the trend. So that means you can see P5 here, that is P5 here, okay, beta times change in the trend. You can see beta times change in the trend plus 1 minus beta times existing trend. So you'll be getting this particular value. So you drag it, okay, then you may have to fix these values, right, to get this particular values, because unless you fix with the dollar sign, it will keep changing. So please fix it. Then you'll be getting the forecast. Now the forecast will have the two different components. One is the calculation that you have calculated, and second one is the trend. That means if you have spent or if you have saved 100 rupees in the bank, then your investment is 100 rupees. So next year, if the bank is paying 10% interest, it should be 110 rupees. So next year it will be 110 rupees plus 10% of the interest. Likewise, it will be you'll be calculating. So this is this one plus this one is equal to this one. Similarly, you just take this way, drag it, and the rest of the procedure I have already explained. So finally, let's see whether this method has any improvement. So 10.91, this is giving as good as result as the weighted moving average. So that means after doing so much of calculation, it is giving 10.91, and this is giving you 10.80. So there is hardly any difference between the two. So we cannot really say that this method is not really working well. Similarly, if you have more interest, you can get into another issue with respect to the hold to interest method. That is actually going to address your seasonal fluctuation. But do not be under impression that seasonal fluctuations, since you have addressed, is going to give you the better result. So let me close this. I'll just share this one with you. Then another thing is that quickly I'll just show you. Then we can take some questions. So then solver, you can also use MATLAB, you can use Tora, you can use QM for window, that is open source. QM for window, that is open source. You can use it. I also use. So there actually you'll be getting the tools or the techniques required for the project management. Or you can get. I can show you quickly. That is some of you may be knowing. That is QM for Windows. Okay, so open source. You can install the software, right? So that will be helping you for few things in prediction, also in optimization. Basically, we use it for optimization. So you can see that, right? So you can do that. So now here, also you can use Excel solver, right? Some of you may be already using. So quickly, I would like to show you that there are few demand points. Okay, that is D1, D2, D3 are the demand points, and these are the supply locations, and this is the matrix that you have available, which is kind of a cost matrix. So S1 to D1, you need to spend 47 rupees per unit. S1 to D2, 40 rupees. S1 to D3, 38 rupees. These are mere random numbers. You can take your the values of your choice. Then you have certain demand in each market, 190, 200, 160. Similarly, from each source you'll be getting the supplies. So 200, 150, and 200. So ideally, if you add these two, okay, this will balance. That is one requirement in the solver, right, or in the optimization problem. So this is column wise 550, and let's say row wise, what is the value? Row wise also this will be same. If not, then you have to add rows or maybe columns to balance it, right? So that is one thing. Then this is actually one more matrix that you can create, okay, with zero, all zeros. Then you can see you can add all the zeros. We'll be getting this value. Then you can drag it. Then you can keep the column wise summation, right? Finally, what you can do is you can go to solver, you can go to data, then you can go to solver. Then what is that you need to do? Basically, this is a multi-market delivery situation where you have to minimize this particular cost. So this cost is nothing but the sum product of this yellow color or the brown color array and this brown color array, right? You keep it the cursor there. Then the additional constraints are basically, or the constraints are basically, demand will be exactly equal to the demand and supply will be less than or equal to the supply, because you cannot deliver more material than the supply, right? So, and as you know that this material, they cannot be negative. So we just use, whether they're zero, this is called as a non-negative restriction. Then you solve it, you get this value. Okay, this is a simple problem of, prescription. That means this is what you need to do. I have shown you for the prediction. This is what you need to do. That means S1 market will be delivering 190 unit to D1, 10 units to D2. There is no supply from S1 to D3 market. Similarly, S2 market will be supplying to D2 market. There will be no supply from D1, from S2 to D1, S2 to D3. Similarly, the S3 market will be supplying to D2 market, D3 market, right? That way, the problem is optimal, or the solution is optimal. The requirement of the customers are met, and the constraints are also met, right? So this is one typical, very small problem, but a very practical problem. And since for demonstration purpose, I have used a very smaller matrix. If you want to use whatever way you want to use, you want to extend the supply base and the demand base, that anyway you can do, not a big deal, right? You can keep adding the rows and the columns, but algorithm remains the same. Now, here another thing, this is a part of, actually, as I said earlier, is a capacity allocation problem, right? For the capacity allocation problem, the same transportation matrix is given, right? And additionally, what is given is basically the supply base, certain additional information for the supply base. So that means if you use this supply base, there is a fixed cost, could be warehousing, could be production, could be anything. So your fixed cost is 6,000, your supply base B 4,500, supply base C 6,500, and so on. Then the capacity of this facility is basically 10 each. For simple calculation, I have kept 10 each. Then initially what you need to do is, I'm getting some noise, I'm going to close, please mute yourself. So then you keep how many plants basically you need, right? Initially you keep 0, 0, 0, then later you can optimize, right? Then this is for, you can say, the low capacity plant. So what is happening with respect to the high capacity plant? High capacity plant means the cost will be certainly higher. Then the capacity that it can handle is 20, maybe 20,000 tons, 22, or maybe you can say 20 lakh tons, whatever we, for simple calculation, I have kept it 20 each. Then you have to keep all zeros. Then just to think of what is the fixed cost. You do not know initially that how many plants you are going to use. Then how do you find the cost, right? So that means, say, number of plant into the cost, number of plant into the cost, number of plant into the cost. That way you can calculate and find out what is the total cost. Similarly, you can take the high capacity plant. So how many plants into what is the cost? How many plants, what is the cost? So that way you have the sum product of this and this plus sum product of this into this. Okay, you will be getting this. So total cost is this much. This is the total fixed cost. Then what is the objective of this particular problem is basically we see the you can say this particular this is your fixed cost and this is the shipping cost. SC is basically shipping cost. You can also say transportation cost. Transportation cost is nothing but sum product of this array. So let me go back, this array and this array, right? That is the shipping cost. So shipping cost plus fixed cost is equal to total cost. Now, like the previous case, go to the solver. You have to minimize this particular one. Then you change the cells. What are the cells that you are going to change? That means you are going to change this particular one. That is, I have already said, that is you are going to change the number of plants. That is I here, this I, okay, and also your L, right? These two things. Secondly, we have to see these cells from here to here to here. These are the cells we are going to change. Then what are the things? As the previous case, demand is exactly equal to demand, supply is less than or equal to supply. Now you must say, what is that is the supply? Supply is nothing but what is the total item that you are carrying. Let's say you are choosing 1 unit from low capacity plant. To only fulfill the requirement of the average demand, then you keep average inventory. That means zero inventory plus Q inventory or the full inventory, you have the half of the inventory. For that may not be true all the time. So that is why we say the cycle inventory is not necessarily equal to the average inventory. It is equal to the average inventory, right? Average inventory plus some safety stock, right? That is actually the buffer stock. So this buffer stock will be depending on your level of the reordering point and the cycle service that you would like to meet in a typical cycle. I'm going a little high level, so hoping that some of you are already into this. So then you get the half of the inventory, right? Then you get the number of orders. What is the number of orders? Number of orders is nothing but the demand by economic order quantity, right? Demand by economic order quantity, you can see B3 sale is this 2000. So every time you order, you get 596. So that way, it is actually not necessary that it will be a whole number. You can convert it to a whole number, because number of orders cannot be a fraction, right? It has to be a whole number. But for simple calculation, I have removed the decimal, so I'm taking 3. So now if somebody is interested to see what happens with respect to the 4, if I take 4, right? If you take 4 instead of 3.35, instead of 3 you take 4, then what happens in the cycle? That also you can check, right?